equivalent. So here you will see parallel, both are parallel. 5 ohm and this 5 ohm is parallel. So that's why we can write this one as 1 by R equivalent is equal to 1 by 5 plus 1 by 5. 5 and this is 2. So I think you have got practice to reverse it. So we will get R equivalent is equal to 5 by 2. That means 2.5. So first question is solved. Number 1. This is case answer number 1. Total resistance. Next come, then what is the current I shown by ammeter? Ammeter is connected through this potential difference, that means cell. So total current shown by ammeter. So for second, answer number 2, we know from Ohm's law that is V is equal to IR. We have 4 volt. So we can write 4. Just I am writing here V is equal to 4 volt. I we have to calculate it, that is circuit current, and R equivalent we have got 2.5 ohm. So here R equivalent 4 is equal to I into 2.5. So what I we will get? I is equal to 4 by 2.5. So what answer you will get? That is 4 by 2.5. 40 by 25, and solve this one, you will get it, that is 1.6 ampere. So answer is 1.6 ampere. One more question. I am showing you how you will solve when there is combination of resistance. Our next question is, 3 resistors are connected as shown in figure. Through the resistor 5 ohm, a constant current 1 ampere is flowing. Let's see, this figure is given. This is our figure. 3 resistors 5 ohm, 10 ohm and 15 ohm is connected to this. And it is given that 5 ohm through 5 ohm 1 ampere of current is flowing. So again we have to find out the conclusion that which is parallel combination and which one is series combination. So you see here parallel combination, from the figure only we are seeing that if current through 5 ohm is 1 ampere and it is flowing, so this current will come up to at branch B, then it will divide through, some current will consume by R1 and some current will consume by R2 depending upon the value of resistance. That means there the current divides, and where the current divides, that is parallel combination. So let us see. First of all, given. Let us take R1 as 5 ohm, R2 10 ohm and R3 15 ohm. R2 and R3 are parallel to each other. So first let us find the equivalent resistance. R equivalent 1 by R equivalent is equal to 1 by 10 plus 1 by 15, that is equal to 150. 15 plus 10, 25 by 150. Just reverse it. So R equivalent is equal to 150 by 25, and that we will get, that is 6 ohm. So we have got R equivalent, that means parallel one. Let us see now the question what we have to calculate. Calculate first case. Now let us start solving first case. Current through the other two resistors. It is given that 1 ampere is passing through 5 ohm resistors. Then what will be the current through 10 ohm resistors and 15 ohm resistors? Directly we cannot calculate it because potential difference, that is for series combination it changes, for parallel combination it remains constant, and for parallel combination we have got equivalent resistance 6 ohm. So now from Ohm's law I am writing V2 through R2, so that is I2 R2. Let us put the value of this one, that what we are getting in this. I2 we have to calculate it. R2 is 10 ohm. 10 ohm, and then what we will take for V, and that V is nothing but that is where we are getting 6 ohm. So we don't have V now. So what we will do for that? Just see. V is equal to IR. IR. This I has only divided in this 2. So we can write this one as 1 ampere, because this 1 ampere is dividing in this 2 into R we have got equivalent 6. So we will get 6 volt. Potential difference we have got, equivalent resistance we have got, individual resistance is given, and then let us find out the current. I we can write V by R. V we have got 6 volt, and R we are getting how much? That is R2. Through R2 we are finding, that is 10 ohm. So first one I through R2. Let me write this. I through R2. So we have got 6 by 10. R2 is 10. V is 6. So what we are getting? 0.6 ampere. Same way, I through R3. V by R3. V is 6 volt. R3 is 15 ohm. 15 ohm. So what you will get it for this? That is 0.4 ampere. In the numerical of electricity, very easy way to check it. How we will check it? Now you see, in series the current remains constant. In parallel the current changes. But when I2 and I3 comes and meet here and passes through the wire through point C, then what will happen? 0.6 ampere, 0.4 ampere. When you will add this, you will get 1 ampere. So 1 ampere is passing through 5 ohm, and again 1 ampere we are getting in the circuit. That means whatever we have calculated is right. So come for next question, that is number 2. Potential difference across AB and AC. So let us check it. Potential difference across AB. AB, A and B. So V across AB, we can write VAB. VAB, what we have? We have R 5 ohm and I 1 ampere. Everything is given. VAB, that is I into R. I is given 1 ampere. R is given 5 ohm. So it is 5 volt. We have got it. Let us find the V through AC. V across AC. Sorry, BC. First we will find through AC and then total we will find BC and total we will find AC. So here you see BC. We can write this VBC. Just now in first cases we have find out this one, that is I R. I we have got again 1 ampere, that is 1 into, and R we have got, that is 6 ohm. So it is 6, so we will get 6 volt. And total potential difference, that is V across AC, we can write VAC, that is VAB plus VBC. So what we are getting? 5 volt plus 6 volt, we are getting 11 volt. So V across AC, that is total volt, we are getting 11 volt. Then come for third case. Third case, what we are having to calculate this one is that the total, third case, the total resistance, and that we have got only total resistance. Now, total resistance is nothing but equivalent resistance, and equivalent resistance for R2 and R3 we have got 6 volt, and that is R1 we have 6 ohm, and R1 we have 5 ohm. So total resistance we will do it R series, because this 2 is replaced by one equivalent resistance 6 ohm. So R's both connected in R series. R series is R through 5 volt, that is R through 5 ohm plus equivalent resistance R, that is 6 ohm. So directly I am writing 5 ohm plus 6 ohm is equal to 11 ohm. So we have got the equivalent resistance. Like this we can calculate any number of resistance. First we have to think about that whether which one is series combination and which one is parallel combination. So you please prepare your NCERT in text question. Okay.